Sir, welcome, sir. Welcome, sir. Suryanan, sir, welcome.
Sir,
Chief guest.
welcome, sir. Welcome, sir. Welcome. On behalf of our institute, we wholeheartedly welcome you, sir. Sir, வந்து மியூட் பண்ணிருக்காரு. மைக் மியூட் பண்ணிருக்காரு. மியூட் பண்ணிருக்காரு.
Welcome. Thank you.
Welcome, sir. Welcome, sir.
Yeah. 1 second.
Yes, sir.
Yes.
Yes, sir.
So let's wait for people.
எல்லாருக்கும்டா ஃபோன் பண்ணி சொல்லிருங்க.
இப்போ சொல்லிடுறேன். இதுதானே சார்?
இது இல்லடா. ஹோம் சென்ஸ் பாரு.
அதான் சார்.
ஓகேடா.
Kumaresan.
குமரேசன்
Yes, sir.
சார்.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
So now I forgot how to share my PowerPoint.
You will have a up arrow button, sir. You just say share, and it will ask for entire screen.
Well,
When you select that window, which is you click on that window.
Okay. Present show. Okay. Select to share window and then entire screen.
Yes, sir.
Okay. So I should have opened that PowerPoint before, right?
Yes, sir. Yes, sir. Yes, sir.
I have done that. Now, okay. Now, Which one should I share?
Now you can just open the PowerPoint, sir. You can view it. We can view it.
Wait. Okay. Wait. I will open the PowerPoint. I have opened.
Now you can minimize this,
Huh?
and so that will be visible. But no, sir. Now you are not sharing.
Yeah, I'm not sharing. Wait.
Uh,
I'm too confused. Okay, one second. So I have to go to here. Then here when I press that arrow, it says Chrome tab, window, entire screen.
yes, sir. Yes, sir. Yes. Entire screen. You can go for entire screen.
Entire screen.
Yeah, that will be better.
Okay. And then
Entire screen. Just select that one, whatever screen is visible. Now.
oh, this is really still easy in the other one.
Now this is fine, sir. Now you have to minimize this, and you can, if you view the PowerPoint, we can view that.
Okay, let me see.
Yes, sir. Yes, sir.
So okay, so what I
Now half screen, like you can make it full screen if when the presentation starts.
begins, right?
Yes. This now if you go, now it is full screen, sir.
It's okay. Now what I will do is I'll ensure and I'll wait for the. Okay.
Yes.
Is
Yes,
that
sir.
right?
Yes, sir. Yes, sir.
Okay. Right. So I'm able to do that. Good.
Kumaresan?
Sir, yes, sir. Yes, sir, yes, sir.
Yes, sir.
ஒரு 2-3 minutes, sir. We'll just start.
Okay, sir. Okay.
ஏன்னா யூடியூப்ல இருக்கிறதுனால யூடியூப் some people are watching in that YouTube. அது I'll just. We'll just wait for a few minutes, sir, then we'll. Sir. Sir, shall we just begin with thing, sir? Shall we begin? Sir, Director, sir, Suryanan, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
We just begin.
Yes,
so
yes, Dr. Kumaresan. Yes,
Yes,
you can begin.
So, on behalf of Kanji Mamuniyar Government Institute for Postgraduate Studies and Research and Mycological Society of India, I take privilege to welcome one and all. First, I would like to welcome our Director, sir, Dr. M. Selvaraj, who has been a very encouraging source to all of us. So when we request for such programs, he immediately agrees, and he says, go ahead, and whatever help he is required, he does. I thank you for all that, sir. I welcome you
Thank you.
from my heart. I welcome our today's chief guest, my mentor, my guide, Professor Suryanarayanan sir. Only because of him today I am here, I would say. And on this special occasion, I thought I could invite him, and he has a very different thinking. So even the title which he has given today is really interesting. People are asking what fungus it is. I said, you join, you will know. So in such a nice person. So about him we'll introduce. So I welcome Professor Suryanarayanan sir, Director, Vivekananda Institute of Tropical Mycology, Chennai. Welcome you, sir. I welcome all the office bearers of Mycological Society of India who have joined. I think Secretary sir said he will join. I don't know whether he has joined, sir. Deshmukh sir is there. I welcome sir. Welcome you. And our colleagues from different our own department, Vikrant sir, Shekhawat sir, Aragaya sir, and from other faculty from other colleges, Saravanan, Dr. Saravanan, and all. I welcome one and all. I welcome all the participants from different places from our country, because there are more than nearly 150 registration. So therefore, we made a YouTube link. So that is also parallelly there. So some people have joined in YouTube link. I welcome them also. I welcome one and all. Before give presidential address, we thought one of our great scientists, father of Green Revolution, who is no more, I thought a few words about him before we commence. We know that he is no more, but he has left behind a lot of things to think about to increase the food production. He was the Director General of IRRI Philippines, Director General of ICAR, and also he was Secretary to Government of India. He has won a number of awards, including World Food Prize, the prize money through which he established MS Swaminathan Research Foundation in Chennai. Then he was awardee of Shanti Swarup Bhatnagar Award, Ramon Magsaysay Award, Albert Einstein World Science Award. Then he was also designated as father of economic ecology by United Nations Environment Program, and finally he was also nominated to Parliament of India. So finally he did his final work in MS Swaminathan Research Institute, and our resource person Suryanarayanan sir is a close associate. He has been there a number of times, close association. He has close association in MSSRF. So what I feel is that as a scientific fraternity, teachers, we should take ahead these ideas, so that to whatever we can contribute some to the betterment of food protection world over. So just a tribute to him, sir. Now I request our director, Dr. Selvaraj sir, to preside over. Sir.
Welcome, sir. Thank you, sir. Happy morning to all. Respected Professor Suryanarayanan sir, respected faculty members of our institute, the members of the Mycological Society of India. At the outset, on behalf of our institute, we extend our sincere wishes to all the participants for today's webinar. Actually, the fungi, you see the interesting fact of the fungi, that is it related with our quality of life, not standard of living. We have already standard of living improved, but not quality of life. The fungi will help us to enhance the quality of life. All the things, the right person is the Dr. Suryanarayanan sir. He will also going to present that webinar. I think it will be more interesting and useful for us. At this juncture, I wholeheartedly thank Dr. Kumaresan and his entire team for their unconditional support for all the activities organized by the institute for the betterment of the student and the society. With this, now I once again thank all the participants. My special thanks to our resource person, sir. Thanking you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you. Now about Dr. Suryanarayanan sir, just a brief introduction about him. He has taught botany for more than 30 years in RKM Vivekananda College, Chennai, and I was his student BSc, MSc, as well as he is my research supervisor, in which I worked on fungal endophytes of mangroves. Currently, sir is the director of Vivekananda Institute of Tropical Mycology, Ramakrishna Vidyapeeth, Chennai. And he has been now presently studying, or earlier also he has been studying less studied habitat, fungi from less studied habitats for their biodiversity, ecology, technological potential, etc. And he has nearly his citations goes to around more than 6,000, which H index of 42, which we cannot even probably dream. And sir's name appears in Wikipedia. So if you type in Wikipedia, sir's name will appear. He has handled a number of projects by DBT, DST, MOFCC, etc. And he has been awarded many awards. Of course, I am just reading a few of them. TWAS Award from Kenya, then Fulbright Nehru Senior Fellowship to conduct research in the Department of Biochemistry, Ohio State University, Fulbright Fellowship to conduct research in Arizona State University, visiting professor in University of Amazonia, then honorary research associate in New Brunswick, then research supervisor, University of Münster, Germany, visiting scientist in the Department of Molecular Pathology, George August University, Göttingen, Germany. Then he has delivered a number of keynote addresses in different places. He has a research collaboration with IIT Madras, IISc, JNCSR Bangalore, then Bangalore Agriculture University, also with Helmholtz Center, Germany, then in Ohio State, USA, Finland, VTT Finland, and Tartu University, Estonia. So his current research, he focuses on using fungal endophytes, because sir is the pioneer, you can say, who studied the fungal endophytes. We started the work in mid-90s, you can say, and still, so maybe sir is one of the authorities, you can say, in fungal endophytes to improve the crop resilience to climate change effects using fungal endophytes to improve the efficiency of biofuel production, exploring endophytes of plants of extreme habitats to find novel antibiotics to manage antibiotic resistant human pathogens. So that is all. So it's a brief introduction about sir. I am really pleased to welcome you, sir, for this, you can say, novel topic, I would say. And also, again, some of our staff like Shekhawat sir and our HOD Nayak sir has joined. I welcome them also. Now I request Professor Suryanaran sir to straight away can just start the your presentation, sir.
Yeah.
Yes, sir.
Oh, thank you, Professor Kumaresan, for that nice introduction. So let me begin my talk by sincerely thanking Professor Selvaraj and Professor Kumaresan for giving me this opportunity. Whatever Professor Kumaresan mentioned as my achievements are entirely due to students like Professor Kumaresan. I say this very sincerely because I've been very lucky in having excellent students. And about citation, Kumaresan's work on fungal endophytes of mangrove was perhaps the first in the world, and it stands very high. That paper which we published has a number of citations. So I'm happy that Kumaresan continues with his interest in teaching and research. So with these few words, I straight away go to my talk. Please tell me if you are able to see the screen.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
So I'll take about maximum 45 to 50 minutes. Is that okay, Kumaresan?
Yes, sir. Fine, sir. Fine, sir.
Okay, nearly an hour. Okay, so so I wanted to give this title so that it will attract people to listen to what this is. Most of you would be thinking that this is these the lead light of potato. No, it's not that. It's a different thing. I'm going to talk about a rubber plant. So when I was a visiting professor in the Amazon for 2 months, I learned about the history of rubber tree. There's no rubber tree is a native of the Amazon. So let's go to this. The rubber tree, Hevia brasiliensis, belongs to Euphorbiaceae and can grow up to a height of 100 feet. It is a native to the Amazon basin. And in fact, you know that you cut the bark and you get this white latex which will solidify, and that becomes the rubber. The ancient Aztec people who were living in those regions, and also people from Mexico, they used this, they made rubber balls from the latex of the tree and they played games with that 3,600 years ago. So they knew about this rubber, and they used to burn rubber balls as offerings in temples. These are all historical findings. And in the 19th century, the people from Spain, the Spaniards and also the Portuguese colonized South America, and especially Brazil was colonized by the Portuguese. And then Brazil became the main supplier of rubber latex to the entire world, because by that time there was a need for rubber throughout the world. And since this plant was growing, this tree was growing only in the Amazon or Brazil, and not only Brazil, in the Amazon region, but most of the Amazon forests are present in Brazil country. So Brazil became the main supplier of rubber to the entire world in the early 19th century. Now, rubber, as you know, it's a polymer of isoprene molecules. Many plants produce rubber. But then why only rubber tree is used for commercial production? Because that tree produces the latex in large quantity when compared to other rubber producing plants. Therefore, people use rubber tree. Rubber is a sticky substance, and why should a plant produce rubber latex? The idea is, I mean, what happens is when an insect bites the leaf or the bark and eats the tissues, rubber is secreted and rubber will stick to the mouth parts of the insect, so it cannot open its mouth again, and so the damage to the tree is very much reduced. So actually, and then rubber, if there is a wound, rubber also is secreted and that will seal the wound, so that through that wound fungi or bacteria cannot enter and cause more damage to the plant. So rubber is produced as a latex by the plant rubber tree for its own protection against pest attack. Now, from the year 1860 to 1913, since the rubber tree was found only in the Amazon forest, the entire world depended on a few business people in the Amazon for the rubber needs, because a few business people extracted the rubber in large quantity and then they started selling it. And since rubber was not available in any part of the world, the entire world depended on this Amazon forest, and that too Brazil, because most of the forest is present in Brazil. Okay, now when the people, when the settlers or the people from Europe, when they settled in the Amazon, when they saw that, okay, we can get the latex and sell it, their idea was, I mean, it is natural that you can make a plantation, bring all the rubber trees, grow in a farm, and then extract more rubber. But when they tried this, it was not successful. Rubber trees cannot be grown close together because they got easily infected by a fungal pathogen. And the fungus could spread easily from one plant to the next, because in a plantation, you have only that rubber plant which are growing close together. So if one tree is attacked, within a few months, all the trees will be attacked. And that fungus causes severe defoliation. All the leaves would fall, rot and fall, and the trees would die. So it was not possible to develop plantations. So that means to get rubber, they had to go into the forest and then choose rubber tree. Wherever rubber tree was growing, just have a look at it. If it is infected, okay, don't use it, go somewhere else. see a healthy tree and then get tap out of it, because the trees were separated from each other. You know, it's a very dense forest with very high diversity. So you may find one rubber tree here, and you have to walk maybe several meters or sometimes even kilometers to find another rubber tree. So that way, because they were separated, the pathogen could not spread from one tree to the other. So most of the trees in the forest were healthy, but people had to go into the forest and every day search for trees and then get the latex from them. Even today, rubber plantations in Amazons are difficult to manage because of this pathogen. Okay, right. Now, what is this pathogen? This pathogen is a fungus, and it causes this salb disease that is called South American leaf blight. It is specific to rubber tree, and the fungus is Pseudocercospora woolii. It belongs to Mycospherulaceae. And so you can see the damaged leaf here, and then these are the conidia. It also reproduces sexually. You see here, when they try to grow rubber in plantation, you see all the defoliation. There are no leaves, and then soon the tree would die. After the death, there is no production of latex. So they even tried to control this salb disease by fungicides or by biological control method, or they tried to even breed for resistance. But all things have failed. Even today, things have failed. Somehow it's very interesting. Probably the fungus has co-evolved with this host plant for a very long time, and it's not easy to control this disease. Here is a life cycle, very, very briefly mentioned here. So you see the healthy leaf of the rubber tree, and when it gets infected, here you can see the rotting of the leaf. These are the early stages, and this is the later stage. And then the fungus produce conidia, asexual spores inside pycnidia, and these are the asexual spores that are released from these spots, and they could easily infect young new leaves. And sometimes when the conditions are favorable, the fungus also reproduces by sexual reproduction, and they produce ascospores within asco, or you call them pseudothesia, because this is a bitunicate ascus loculoascomycetes. So you see the bitunicate, and then the spores are released, ascospores are released with great force, and they float and they can infect the new rubber trees. Now the problem with rubber tree is when you see, I mean, if there is a rubber tree, we just cannot go and tap it. The tapping should be done at a particular stage of the plant. It should be mature enough to give the latex. So, well, so far what we have seen is rubber tree produces more rubber latex than other trees. Therefore, it can be commercially used. Good. Rubber tree is native to the Amazon region. It is not found anywhere else in the world. So people have to depend on the Amazon zone for getting the rubber. 3. The tree has to be at a particular maturity stage to get the latex. And if one tree bark is cut and you get latex out of it, we cannot get it again. Number 4, we cannot grow these trees together in the Amazon because of this fungus. So one has to go into the forest, hunt one tree after the other tree. Suppose I go into the forest, cut a tree, get the latex. Tomorrow I cannot take latex from that tree again. I have to go again and search for the tree. Because of the high diversity, you get different trees, different species of plants within one square kilometer. It's very, very highly diverse and dense, the Amazon forest. So one has to search for the rubber tree, that too of a particular age. So your task becomes more and more difficult as we extract rubber from the wildly growing rubber trees. Okay. Now, in the Amazon, so let's say this is the Amazon forest. So this is South America and this is Brazil. And then these are all different parts, Peru and Colombia and other things. So you see a part of the Amazon forest in belonging to this probably Peru, and this one belonging to the Colombia, and this one. But you see, the major forest is belonging to Brazil. The whole, from here to here, it belongs to Brazil. And in Brazil, where the Amazon River flows, there is a place called, there is a small city called Manaus. Right in the middle of the dense forest, there is a place called Manaus. And Manaus city is situated in the heart of the Amazon rainforest of Brazil, where the Amazon River, so this is the Amazon River. This is called River Negro. I'll explain that. And this is River Solimões. This is coming from different part of South America. This is coming from a different part of South America. They come together and join, these two rivers join in a place called Manaus. And that place, the river is so deep, heavy, so much of water, that ships which are navigating in the ocean, they can come here. And it is here in the Manaus state that the river, Amazon River, enters the sea. So it is easy for ships to travel here and to collect the rubber from this place. That is how Manaus became a very important place. So, people go into the deep into the forest and then collect all the rubber latex and bring it to Manaus. And here you have, storehouses of rubber latex in sheets. They will store it, and the ships could come from Europe and other places, and then they could take this and go. So that is how Manaus became a very, very important place, because it was exporting rubber to the rest of the world. Okay, so in Manaus, as I told you, remember there are two rivers. See here, this is called Rio Negro or River Negro, which is coming from Colombia, and this is another Amazon river called Solimões, which is coming from Peru. These two huge rivers will join in Manaus to become even more huge, and that is the major Amazon river. So here in Manaus, the dark Rio Negro, Rio in Portuguese, Rio is river, Negro means black. So that river is coming from Colombia. It will be black in color. And then there is a pale yellow colored river which is coming from Peru, and it is called Rio Solimões. So the Black River and the White River. Black River comes from Colombia, White River comes from Peru, and they meet in Manaus. And then, even though the two waters meet, they don't mix. For 6 kilometers, the two river waters, even though they touch and flow, touching each other, they will not mix. You can see the two rivers side by side. Why do they not mix? Because they differ in temperature, speed, and amount of dissolved sediments in the water. The Black River flows at the speed of 2 kilometers per hour. The White River flows at the rate of 6 kilometers per hour. The temperature of Black River is 28 degrees Celsius. The temperature of the White River it's cooler, 22. And the Black River flows through rainforest of Colombia. So it falls through the mountains. It collects all the the litter, the debris, the plant remains. That is why it becomes very black in color. It will be pH will be low, 4 4.5, whereas the light colored river, which comes from Peru, is coming through the Andes Mountains, and it is not black in color. It doesn't have much of plant remains, so its pH would be nearly 6.5 or something. And you can see here, see, this is a photo I took when I was traveling through the water. You can see the black water here, and you can see the white water here. See, they will be running side by side. They don't mix for a long period. So it's a very interesting. This is just a shot of the Amazon River in the twilight when the sun is setting. Okay, so now, right. So this is about the rubber tree, Amazon, and the importance of that town called Manaus, which is situated in Brazil. Okay. Now about rubber. Though rubber was not found elsewhere in the world, and people got rubber from Amazon through ships, in the year 1770, an English engineer by name Edward Nine, he accidentally discovered that if this rubber could erase pencil marks on paper, and the rubber that we use, we can wipe out the pencil marks. And because of this, he became very rich by selling erasers made out of natural rubber. He sold it at very high price and he became very rich. So, because it is able to rub the pencil mark, it was called rubber, and even today we use the term rubber. Rubber is waterproof, as we all know. Therefore, in the year 1823, another British chemist, he by name Mackintosh, he produced raincoat using rubber. Even today, raincoats are called Mackintosh. And he became very rich. But then there was one problem with this rubber material, anything made out of rubber, because rubber became brittle. It breaks into pieces when the temperature is less than 10 degrees Celsius. So during winter, in all these places, winter will be cold. Whatever rubber, if you use rubber shoes or if you use rubber raincoats, they broke into pieces when the temperature in winter. And when the temperature is high, they got stuck together. So rubber was okay as long as the temperature was more than 10 and less than 50. So then people thought, the scientists in Western countries, they tried several methods to improve the quality of rubber. They used nitric acid to improve the rubber's weatherproof capacity, but other things they used. But what happened was every treatment worsened the quality of rubber. It made it more bad or worse. So they didn't know what to do. So there was a demand for rubber, for making shoes, for raincoat, all that. But then, there was always this problem. So they were wondering if we can somehow make the rubber more suitable, make it, strong, then the use of rubber would increase. During that time, in 1839, an American scientist by name Charles Goodyear, so based on him, that Goodyear tire company and all those things are now there. This scientist, he was working earnestly for several years to find out if rubber can be made better. He lost all his property in this work. He became poor. He borrowed money from people, but he couldn't repay them, so he went to jail. And then he even sold his children's school books to get money for doing this experiment. So he was very, very focused, and then finally one day, accidentally he dropped rubber in sulfur on a hot stove. You see the combination. It should be hot temperature, sulfur should be there, and rubber. He dropped rubber and sulfur together on a hot stove, and that made it char like leather. But the rubber, the plastic nature of the rubber, the elastic nature of rubber was maintained, and the rubber did not break at low temperature, or it did not become sticky at high temperature. And he called this process as vulcanization. And this accidental discovery, uh, when it was done, it was extremely, people were extremely happy. Now we could make rubber which is more durable. And by that time, um, Henry Ford started manufacturing car, and for car automobiles, tires were needed. And Goodyear showed that if you get tire and if you can vulcanize it, then you can use it. So then rubber was used for waterproofing, for wearing rubber shoes, and then raincoats, and then for preparing cycle tires, tires for cars. And there was industrialization everywhere. Like for industries, you needed a lot of motor, and for motor wheels to work, you need a rubber band, thick rubber bands are needed. But those bands, when you work on it, because of the heat, the rubber band they were destroyed. But if you use vulcanized rubber, there was nothing happened. So industrialization took place because of Goodyear's accidental finding. Then the demand for rubber increased throughout the world. Europe and USA wanted more and more of rubber. And this city, Manaus, which was exporting rubber, which was in the middle of the forest of Amazon, people there, a few people who were doing business, who were selling rubber, they became very, very rich in a very short period because of these discoveries. So how did Manaus become rich? So here is the Amazon forest. You see just a picture. I took it from the Shutterstock or whatever. So you see the Amazon forest. It is there in Venezuela. It is in Colombia. It is to some part in Ecuador, some in Peru, some in Bolivia, all those things. But majority of the forest is in Brazil. And you see here Manaus, and that the rivers joining, and it is very close to the Atlantic Ocean. So the ships could come here and then collect the rubber and go back. And here is the aerial picture of it's one part of Amazon forest. You see the river flowing, but you see the dense cover. So, you may find one rubber tree here, another rubber tree maybe here. You have to probably walk hundreds of miles, sometimes one very close to the other. You have to hunt for this to collect the rubber. So, because of the demand for rubber after vulcanization, as I told you, export of rubber from Manaus took place in very, very great, in large quantity. So in 1840s, Manaus became very rich. Manaus had the Brazil's first telephone system because they had a lot of money. 16 miles of streetcar roads, which sounds very simple today, but in those days it was really a long road. And it had an electric grid for a city of 1 million people, although the population of Manaus was just 40,000. Lot of money was made by business people, rubber businessmen. They lighted their cigarettes using 100 rupee bank currency notes. And then what did they, instead of giving water to their horses, they filled silver buckets with the French champagne, which is very expensive, and then gave it to the horse, fed thirst to slake the thirst of their horse. They ate food imported from Europe. The food has to come from Europe through ships. They celebrated dinner costing 100,000 US dollars. Imagine, in 1840. And during that period, Manaus was the place which bought maximum amount of diamond in the entire world. So they had that much money. This should be bought. Okay. So not only that, because they had so much money, and for entertainment, because they are in the middle of a dense forest, and there is nothing there for entertainment. So for entertainment, they built a theater called Teatro Amazonas in Portugal. That is Amazon Theater. The construction of the theatre was initiated by the then governor Ribeiro in the year 1884, and it took 12 years to complete. The dome of the theatre, even now it is there, and it's a tourist attraction. The dome of the theatre is covered by 36,000 marble tiles, which were got from France, and they were given the color and arranged in such a way that it would resemble the Brazilian flag. All the material for construction of this theatre, they were imported from various parts of Europe. The staircases and the pillars were made of Carrara marble tiles from Italy, very expensive. Steel walls and gates were imported from England, and the glass was imported from Bohemia. You see, this is the theatre. I visited this theatre. See here the dome made up of tiles, which is colored like the Brazilian flag, and this is the steps leading to that. And then the seats were Louis style furniture from Paris. 198 Italian crystal chandeliers, including 32 made of Murano glass. I don't know what that Murano glass is, but I found that in the Google it says it is very expensive. They are all present in the ceiling of the theatre. And then to increase the acoustics, the sound waves when somebody is dancing or when there is a drama, how did they do it? They made a hollow vibrating pillars from cast iron, which was got from Scotland, and they placed it at different strategic locations in the hall. And that way, because of the vibrations, the acoustics improved. The hall can seat 700 people. It has a ceiling painted by the then Italian artist Domenico De Angelis. He came from all the way from Italy to paint these ceilings. And then the main road in front of the theatre, which is here, the main road in front of the theatre, what they did was they covered it with rubber, so that when the people traveled, they were traveling by what you call as chariots, and so when they travel, the sound of the wheels did not disturb the people who were inside the hall listening to some performance. So they reduced the sound of the traffic by lining the street with rubber. But they had a very luxurious life. Here is the hall, main hall. You can see the chandeliers, and here you can see the painting on the roof done by that French artist. And here is one of the chandeliers, one of the 198 chandeliers, Italian chandeliers in the hall. Well, okay, so fine, they had a lot of money. And I don't know whether I told you here, maybe did I tell you? So they had so much money that their laundry, their dress were sent to France for washing and ironing. And it is said that the ladies traveled by ship to France to get makeup and haircut and all. So that much money they had, but all from exporting rubber. Okay, but the problem is rubber had to be tapped from wild trees which were not growing close to each other in the forest. So rubber has to be searched, the tree has to be searched, and deep into the forest in different places. So what the rubber barons mean the people, rich people who are doing rubber business, what they did was they used the native people of Brazil, called the native Indians, because Columbus mistook South America for India, and they were called Indians. That's not a it is not a good term nowadays. They don't use it. So native people of Brazil, they were used for tapping rubber. They were sent into the forest for tapping rubber, but they were used as slaves by the rich people. So these are the people, and usually the majority of the native people belong to a particular tribe called Putumayo, and from Peru, and they were slaves, and so they were treated very badly. See the one person who had died. See the this is his leg. Can you imagine how the ribs, and so absolutely very cruel life. One person, one businessman by name Arana, Julius Caesar Arana, um, had a company called the Peruvian Amazon Company. He had an army of. So what he did was he had many. He had many of these native people as slaves to collect rubber. But if they go into the forest, they could escape. They could just not return, and it's difficult to trace them. So what Arana did was he hired around 200 people from Barbados, and he supplied them with guns. The 200 people managed the slaves. So they saw that the slaves worked without rest. So if somebody escaped, they would recapture that fellow and kill. Or what they did was they kept the person's family, wife, children, in a small hut. And they said, you have to go and collect rubber and come back by this day. If you don't return, your family would be killed. So later, the Putumayo people, they filed a case. This is much later. They accused Arana of genocide, but he escaped prosecution. We will see how that happened. So here is another photo from the Google Survival International 1907. See the plight of these natives. They will be given some money, a little amount of money, and they would be told, okay, go and get rubber. When you bring the rubber, we will reduce the debt. But actually, it was a slavery, and the debt increased. Many people were mutilated. So like if they don't get enough rubber, the 1 year would be cut off, and then nose would be cut off, or many of them were killed, and many villages were destroyed. Many women were raped, murdered, children, as a deterrent against those who wanted to escape. So it was a very deadly thing that happened. Now, as I mentioned, rubber trees were growing wildly and not in groups, deep into the forest. The native had to choose a tree of the right age to tap. Once tapped, that tree cannot be tapped again for some time. So every day, the natives had to wander deeper and deeper into the forest, searching for the right tree. Can you hear me?
Yes, sir. Yes, sir. Yes, sir.
Okay,
yes,
because there is a power cut here. Okay,
yes.
so for extracting 4,000 tons of rubber, Arana's company killed around 30,000 natives. You can calculate that is one dead slave for 4 tires of a car. And apart from that, excuse me for a second. So apart from that, many slaves also died due to malaria and yellow fever infection when they went deep into the forest, where mosquitoes were breeding in large quantity. Okay, so here you can see a picture. The natives with the load of rubber weighing 75 kilos, and they have to carry that roughly about 75 kilos for about 100 kilometers with no food given by the company. On the way, whatever fruits they got from the tree or they had to dig out some tubers from certain edible trees and then edible plants and then eat it. It's a very tough thing. And later on, Arana was, there was a case against this Arana, but he escaped punishment by bribing the government, then by corruption. And also, not only that, he became the senator of Lima. Interestingly, when he died at the age of 88, he had no money and he died in a small house in Lima. What happened to all the money? There are a few historical, indications. If this lecture of mine is actually from a paper which I published along with a professor from Amazonas. I will mention that at the end. So if you are interested, you can read that paper. That will give you more information. Okay. So during the here is an example of that court case. So testimony by men. One of the I told you that Arana hired people from Barbados as guards. So one of the guards was questioned by the judge. The judge asked the army man, the guard, and you say you saw the Indians burnt. They were burnt alive, the natives. Then the guard recruited by Arana says yes. Judge asks, burnt alive? Guard says yes, alive. Describe this. Then the guard says, only one I see burnt alive. He had not work. So he did not work, he ran away. So they caught him and they cut off his 2 arms and legs by the knee, and they burnt his body. The judge asked, are you sure he was still alive after cutting the leg and all that? He was not dead when they threw him on the fire? The guard says, yes, he was alive. I am sure of it. I saw him move, open his eyes, and he screamed out. So you can see this in Counsel General Casement, Puducherry report. So, see how inhuman the activity of Arana. It is not only Arana. Arana is one example whose we have more information about his activity. There are others like him. Right. So in the year 1907, the most important center for rubber collection was tropical South America, and that is it supplied about 60% of the world's requirement. But Asia, nothing. It contributed just 3%. There were no rubber trees. Other trees were used, and they were not very good. Today, 80% of the rubber need. What is the rubber need? 9.7 million hectare of rubber plantations. Totally there are 9.7 million hectares of rubber plantations. I told you rubber plantations cannot be made, but you have 9.7 million hectares of rubber plantation. 80% of that is in Southeast Asia. You see them in Indonesia, Malaya, and Thailand. So Indonesia is now the world's largest production of natural rubber. Indonesia, along with Malaysia and Thailand, they have rubber plantations. 2 questions. 1, rubber is not native to their place. 2, rubber tree cannot be grown in plantation because of the fungal attack. Then how is this done in these places? We will have a look at it. First thing, rubber, here is the rubber production. You see here, see the production of rubber? Thailand, Indonesia, Malaysia, India, Vietnam, China, Philippines, Cote d'Ivory, Nigeria, Sri Lanka. These are the major producers of rubber. None of this country had rubber as a native plant. So all the rubber plantations here had come from the rubber from here. How did the rubber come from here to here? That's a very interesting question. There was this Britisher who was more an adventurer traveling around the world. His name is Henry Wickham. In 1876, this Wickham came to Brazil or Amazon, and he stole rubber seeds from the Amazon, and then he took them to England. Now, why do we say stole? See, people were allowed to take biological specimens from Amazon to the rest of the world, because you see so many rare type of animals, birds, insects, type of plants which don't which you cannot see in other parts of the world. So okay, so you can come, but then not seeds. Seeds were not allowed. So, but dead birds, and then you take kill a bird and then make a taxidermy thing out of it, and that can be taken. Animals can be taken, so, but not the seeds. But this person, Wickham, took 70,000 seeds of rubber. And when we were taking things from Amazon, you have to give a declaration. I am taking these things. So he didn't say 70,000 live seeds of rubber, but what he said was, I'm taking some things for academic specimens. They were not viable seeds. That's what he said, but they were viable. And he shipped them to England. He gave the seeds to Hooker, Bentham Hooker, Hooker. He was the director of Kew Gardens. And the seeds were given to him on June 15th, 1876. But out of the 70,000 seeds which Wickham brought, only 2,700 seeds survived. They could germinate. But that was sufficient for the British to send these live germinated seeds to different parts of Southeast Asia. Because at that time, Southeast Asia were colonized by the British. Sri Lanka Ceylon, what was called Ceylon belonged to Britain. India belonged to Britain. And then parts of Indonesia. So these were all colonies of the British. So they sent these seeds there, because the climate in these regions would be similar to that in the Amazon, tropical. So they said, okay, let us try and plant them in these places. Let us see if it grows if they grow as a plantation, Southeast Asia. The country Peru calls the action of Henry Wickham like this: it is the greatest act of biopiracy in the 19th century, and maybe the greatest act of biopiracy in the history, citing that the seeds were never properly recorded on the ship's manifest, and that the resulting plantation in Asia completely deflated the rubber boom in South America. South America's rubber monopoly was destroyed. Okay, so Wickham was paid by Royal Botanic Gardens, Kew, to collect the seeds. So it was not that Wickham went there and then he had an idea of collecting the seeds. No, even before his travel to Amazon, Royal Botanic Gardens paid him and asked him to collect the seeds and to declare them as, in a false way, as academic specimens. It was just a theft. The British first planted the seeds in Sri Lanka. It was then called Ceylon, as you know, and then Malaya, now called Malaysia. Amazon, then the plants started growing, and then Malaysia and Sri Lanka produced a lot of rubber. And because these two countries belong to England, then the England collected all the rubber from here, and then they sold it, and England became rich, and Amazon lost its monopoly over rubber. Many rubber barons or businessmen suddenly turned poor. Some of them even committed suicide. This is Hooker. These are the seeds of rubber, and you can read this book, The Thief at the End of the World, Rubber Empire and Obsession by Henry Wickham. He's called it a thief. Anyway, so that's it. Now, when the rubber grew as a plantation in Asian countries, the production of rubber from Asian countries like Thailand, Indonesia, Vietnam, Sri Lanka, and Malaysia increased. So they needed more people to come and tap the rubber and all that. So then people started migrating especially in the 1980s from southern India, especially from then called Madras and now the Tamil Nadu. Many people moved to Malaysia and also to Sri Lanka as workers in rubber plantation. So they were recruited for tapping rubber, but they also faced many difficulties because malaria was a major problem in especially in Malaysia. Well, malaria was a problem in southern India or even in Tamil Nadu too, but probably the strain was different. Malarial is not clear, but many people, especially from Tamil Nadu, who migrated to Malaysia, died of malaria. They were highly susceptible to the disease. Then there was poor sanitary conditions existing in the plantations. The death rate of the migrant workers was very high, 8% in some plantations. Okay. Now, why is it that the rubber plant could grow as a plantation in Southeast Asia and not in its native place? Well, the explanation could be that the pathogen is not present in the Southeast Asian countries. Okay, so that way, therefore, the plants could be grown as plantation, rubber could be grown as plantation. But we should remember one thing. So many thousands of hectares of rubber plantation existing today in Thailand, Indonesia, Vietnam, Sri Lanka, Malaysia, and in India are all originally from that 2,700 living seeds which came from the Amazon. So you see the number of seeds from that they produce more trees, get more seeds again, plant them. So it was from a very small population of 2,700 seeds that you have a huge plantation throughout Southeast Asia. So there should be definitely genetic similarity among this population. Genetic variation could not be high. So if in one place, if the fungus occurs, then it could spread throughout and the rubber industry could collapse even in Southeast Asia. So that is important. So quickly, the summary. The rich life of rubber barons in Manaus, in the state of Amazonas of Brazil. The enslavement of the natives by rubber tapping. They are being tortured. Biopiracy of rubber seeds by the British from Brazil. Large-scale plantation of rubber in Southeast Asian countries. Migration of workers, mainly from southern India to Malaysia. These are all due to the fact that rubber plantations could not be established in South American Amazon rainforest, which is the native place of the rubber tree. And that is because of the fungal pathogen. So the huge plantations in Southeast Asia have developed from a few seeds. So there is not much genetic difference among them. If the Salb disease attacks, we can expect another collapse of the rubber production in Southeast Asian countries. So all these points are due to a fungus. So that's it. My sincere thanks to Dr. Kumaresan and Professor Selvaraj for giving me this opportunity to share my experience with you. If you're interested to learn more, I could not pack a lot of information because the time is short, and so therefore you can read, get more information from this paper of ours, From Forest to Plantation, a brief history of the rubber tree. It was published in 23 by me and Professor Azevedo in Indian Journal of History of Science. It is available freely on the net. So thank you very much, and I'll be happy to answer if there are any questions.
Thank you, sir. Thank you for taking this in the form of a nice story. So we could know, just like we are in Amazon, that is the thinking what we got. So thank you, sir. Now I request the participants, if you have any queries, can ask discussion. So now later, sir, our members, SK Singh sir, also joined, and also Deshmukh sir had also joined.
Oh,
And sir is there. Deshmukh sir is there, I think, sir.
oh, Professor Deshmukh, thank you for joining.
So I have one question, sir. Do we this fungus, has it been reported, sir, from this part so far? No, no, sir.
No, so far I don't think. I also looked up whether they have changed the name taxonomically, if there is any nomenclatural change. No, so it has not been reported.
Okay, sir. Okay. So any questions from the audience? Anything you would like to ask, especially students? Because most of us, we have not seen actually rubber tree. Maybe from far we have seen when we moved, maybe Kerala or so.
Yeah, in Kerala, yeah, that's a place where they are growing, and they have this rubber research station there.
Yes, sir. Yes, sir.
Yeah, that is there.
Yeah.
But I think slowly the dependence on rubber is becoming lesser because of the synthetic rubber that is being produced,
Produced. Yes, sir.
more effective. Yeah.
Yes, sir.
But
So there are some feedback, sir, that it says very interesting information. Thank you. So
thank you.
that they have given. Yes, sir.
So I would prefer some questions, so it will be nice to interact. See, some science questions. Anyway,
Sir
anyone?
Deshmukh sir is there. Yes, I think he's.
Yeah. He told me he will be joining today.
Yes.
See, what will be the climatic difference from that where it was originally growing in Malaysian countries?
Sorry, Doctor.
See, what is the climatic difference in these 2-3 countries?
Oh, okay. So the British chose the regions in these countries which were similar to that found in the Amazon, and not exactly same, because in Amazon is so dense that when we enter the forest, when we look up, we can't see the sky. The canopy of trees will overlap, and we cannot. So, but the temperature and the rainfall is in some places in Southeast Asian countries are similar, so that it became suitable for rubber plantations to be raised. Because artificial watering is also there, pumping water into the plantation, that is there. So they are able to manage.
Prema Sinakano has raised her hand. Please, you can ask question.
Oh, Rajagopal. Yeah.
Yes, sir. Prema Sinakano, whether you raised hand, any question? So I think we are understood it, like you have taken in the form of story. So queries are.
Yeah, there are two possibilities, but there are no questions. One, it was a clear lecture. Another one, it is not interesting. Too complicated.
It's a clear picture of the entire. It was like a story, as I mentioned.
Oh, yeah.
Yes, yes. Shall we? Okay.
So I wanted to impress on people that studying mycology is important, like any other field. How one fungus was responsible for all these things. That's why the title, I gave the title like that.
Yes.
If that fungus was not there, or if it is not pathogenic, then we would still be depending on Brazil for rubber. They will grow it in plantation. They won't. And now it is not. It's a crime to steal things. Biopiracy, as you know. Now people cannot go and get live thing, plant material from one place to another.
Yes.
So Brazil could have done a great job. It's all because of this fungus that all these things happened.
Yes. Yes, sir. Still. So I request now Dr. Vikrant sir to propose formal vote of thanks. Vikrant sir.
Am I audible, sir?
Audible, sir.
Yeah, you are. Yes.
Okay, sir. Good afternoon, everyone. Respected Director, sir, Dr. Selvaraj, sir, KMGIPSR, and respected and our chief guest, Dr. and Professor T.S. SURYANARAYANAN, sir, respected members of the Mycological Society of India, and head of the Department of Botany, B.K. Naik, sir, and of course, program coordinator, Dr. V. Kumarisan, sir, and one more, Dr. Sunil Kumar Desmukh, sir, and faculty members of KMGIPSR and other institutes, and dear students, and all the participants. It gives me immense pleasure indeed to propose words of appreciation on this occasion. To begin with, I extend my sincere thanks to our director, sir, Dr. Selvaraj, sir, KMGIPSR, for being with us and involved in this today's seminar. He could show his interest in the field of the fungus and world of the fungus. So thank you very much, sir. And then it goes to our chief guest and the speaker, Dr. Professor Narayan, sir. I have heard you, sir, for the last 20 years with my colleagues, Dr. Kumarasan sir's name. You have been his supervisor, and I was not much aware about your work. I could see your journey, academic journey, and even today's your lecture. Your lecture seems to be very much complex. Even you could discuss so many issues connected with one fungus. It was a beautiful presentation, sir. I think that how nicely you have been able to connect the single fungus with the other sections of your lecture, migration and biopiracy, and of course collapse, financial collapse altogether. So it definitely indeed, sir, it's a good presentation, and we have been able to learn many things. And it was a very simple way of narrating the story for the person who is not aware about the fungus as well. So for on this occasion and for the celebration of the World Fungus Day, it has been wonderful to listen you, sir, and we have been very much thankful for your entire lecture and speech, sir. Then it goes to I also equally thank to our Mycological Society of India in general and Dr. Sunil Kumar Desmukh, sir, in particular, for making it possible and attending this whole this webinar. And it is a kind of connection between this KMGIPSR and Mycological Society of India for bringing together this celebration as a whole. Then it goes to that our head of the Department of Botany, I extend our sincere thanks to our Dr. Naik, sir, for being with us and encouraging us to arrange such programs. Then, of course, the program coordinator, Dr. V. Kumarisan, sir. I could see that the connection between teacher and the student. As in the lecture, Dr. Suryanarayanan sir said in the beginning of his lecture how beautifully he connected that Dr. Kumarisan sir, his role, his dedication whenever he used to be a student. So I feel it was a kind of a very good association, and I could see the teacher and student belonging to the same field, and how nicely arranging this whole seminar or webinar. So therefore, I thank to Kumaran sir as well. Then I thank to other faculty members of KMGIPSR like Argaya sir, Dr. Sakawat sir, Dr. Anandi madam, Dr. Janki madam, and other all members who have been associated with this webinar. And of course, all the in general all the participants, and in particular the students who have who have taken out the precious times even on Saturday, and for that I think we should be thankful to them as well. So all together, once again, thank you very much, you one and all. Thank you so much, sir.
Thank you, sir. Thank you.
Kumaran sir, please.
Yes,
What
sir.
will
Yes,
you?
thank you. Yes, sir. Thank you. Thank you for your nice words, sir.
Thank you. Thank you so much.
Thank you. Thank you. Thank you. So I thank one and all once again. Sir, anything we can? Anyone wants to say something? Anyway, vote of thanks is over. Somebody join. Some people join now. That's all.
Dr. Kumaran, can I have a word? So,
Yes.
I enjoyed giving this talk, and I am thankful to all the participants for spending their time. And I am really honored that senior scientists like Professor Sunil Kumar Deshmukh could attend, and then many students. I hope they get inspired by the experience that I had. And my special thanks to Professor Kumaresan and Professor Selvaraj, Director, for again giving me this opportunity to talk to you, and Dr. Vikrant for his nice vote of thanks.
Thank you,
And
sir.
if
Thank
there
you,
are
sir.
any questions, if you have the students, if you have not raising it here, you can always send emails to me. I would be happy to try to answer them. Thank you.
Yes. Yes, sir. So, thank you, sir. Thank you. Shall we? Yeah, sir is typing email address. Shall we, sir? Shall we? Shall we close, sir?
Yeah.
Yeah. Okay.
Unless there are questions, we can.
Yeah. Okay, sir. Okay. If there are no questions, I'll just I thank one and all once again, and probably more. We can have more such lectures. Maybe since it is World Fungus Day celebration, many other institutes are also organizing at the same time. So all the mycologists may be busy with other things. Since it is there in YouTube, they can watch, sir. We can watch at any time. The link is provided, so they can watch it. Yes, sir. Thank you, sir. Thanks a lot, sir. Thank you. Yes, thank you. Thank you. Thank you, sir. Thank you. Thank you. So we shall close down. I thank once again. Thank you.
Thank you. Thank you, sir.
Thank you.
I'm just closing, sir.
Yeah.
Thanks a lot. Yeah.
Thank you, sir.
Thank you, sir. Thank you.